Welcome to another episode of Organic Chemistry Made Easy. We're going to talk about hydrocarbon derivatives and 7 exciting and different functional groups. A hydrocarbon is made up of carbon and hydrogen atoms. On the other hand, hydrocarbon derivatives contain different elements attached to the carbon instead of only H. Hydrocarbon derivatives contain at least one element other than hydrogen or carbon, such as oxygen, nitrogen, or one of the halogen atom. Most of the time, the atoms present in a hydrocarbon derivative are attached as part of a distinct group, and these groups are what we know as functional groups. And these functional groups are what we are going to get to know more today. First off, we have alcohols. Now this contains the hydroxyl group. To name alcohols, you're going to take your base chain name and change its ending to OL. For example, we have ethane with 2 carbon atoms. Instead of having another H here, we would have an OH group on the side. So instead of this being ethane, this will become ethanol. Ethanol, also known as the ethyl alcohol, is a drinking alcohol, although it is still considered a poison, which is why when too much is consumed, deleterious side effects may take place in the body. Another common alcohol is isopropanol, or isopropyl alcohol, which is most commonly known as a rubbing alcohol. It is used as a topical antiseptic. Alcohols can be classified as either primary, secondary, or tertiary. Their classification is dependent on the number of carbon atoms attached to the carbon bearing the hydroxyl group. Ethanol is an example of a primary alcohol. This means that the carbon that the OH group is attached to is only attached to one other carbon. In the next example, the hydroxyl group is attached to a carbon atom that is attached to 2 other carbons. So, isopropanol is a secondary alcohol. And lastly, we can classify tert-butanol as a tertiary alcohol. This means that the hydroxyl group is attached to a carbon that is also attached to 3 other carbons. The next functional groups that we are going to talk about are aldehydes and ketones. These two are clumped together because they both contain carbonyl groups. A carbonyl group is a group with a carbon atom that has a double bonded oxygen. If the carbonyl group is found on the end of the chain, it is an aldehyde, but it is a ketone if the carbonyl is found towards the middle or in the center. To name aldehydes, we simply change its ending to al and -one for ketones. In the example, we have 3 carbon atoms present, so we will make use of the base chain name propane. And since the double bonded O is found at the end of the chain, this means that the compound is an aldehyde. We will take its base chain name and change its ending to Al. Its new name will be propanal. However, if the carbonyl group is found towards the center of the chain, this indicates that the compound is a ketone. So, to name this, we will again take its base chain name and change its ending to ONE, giving us the new name for the compound as propanone. Propanone is also known as acetone, and this is what we use as a nail polish remover. One common example of an aldehyde is methanol. Its common name is formaldehyde, and it is used as a preservative. We also have acetaldehyde or ethanol, which can be found naturally in ripe fruits. It is also the chemical that causes hangovers. Ketones and aldehydes are formed using alcohols. Primary alcohols yield aldehydes, and secondary alcohols lead to a ketone. Next up, we are going to talk about carboxylic acids and esters. Carboxylic acids are going to have a carbonyl group that is single bonded to an OH group. Carboxylic acids are named by adding oic acid to the base chain name. One example is the methanoic acid or formic acid. This is the substance that makes ant bites hurt. This is the poison that goes into us and our bodies react by itching and by swelling. Another example is ethanoic acid. It is more commonly known as acetic acid, and it is the main component of vinegar apart from water. If we take a ketone, aldehyde, or alcohol, we can turn them into some of these carboxylic acids when they react with water. Esters, on the other hand, are kind of similar, but an ester is going to have a double bonded oxygen, a single bonded oxygen, but no hydrogen atom on the other end. Esters are formed when a carboxylic acid reacts with an alcohol, releasing water. The ester is gonna be in the middle of the chain. So when you name them, you have to separate out the group that doesn't have O's in it and the group that does have oxygen in it and name them separately. In the example, we have one carbon with the ester group in it. So that's going to be methane with the ending changed to O8. Next, the alkyl group has two carbons, so that's going to be ethyl. The alkyl group is mentioned first, followed by the O8 group, giving us the compound name ethyl methanoate. Esters generally give us fruity scents, just like ethyl methanoate, which has the characteristic smell of rum and is also partially responsible for the flavor of raspberry. Next, we have amines. These are substances which contain the NH2 group off the side. Amines are named by adding the suffix amine to the hydrocarbon name or amino if the group is with another functional group. If there's only one carbon atom, it's going to be methylamine. But in the example, we have two carbon atoms, so it's going to be ethylamine. Lastly, we have ethers. These molecules contain a lone oxygen with hydrocarbon chains bonded to each side. When you name ethers, you are just going to take what alkyl group is attached as a side group and add the word ether. Now, let's have some examples. This side group has only one carbon atom, so it's going to be methyl. On the other side, we also have a methyl, since we also have one carbon atom. This one is going to be methyl-methyl ether, or simply dimethyl ether. We use the prefix di to indicate that there are two methyls present. Next, we have a methyl, since we only have one carbon on the left side group. And we also have an ethyl because the other side group contains two carbon atoms. After naming the respective side groups, we are now going to arrange them alphabetically. So, this compound will become an ethyl-methyl ether. And that was all of the 7 functional groups that we were going to talk about. Today, we have learned about hydrocarbon derivatives. These are compounds that are made primarily of carbon and hydrogen atoms with specific groups of atoms attached. And these specific groups of atoms are what we know as functional groups. In today's lesson, we've learned about 7 of these functional groups. We have alcohols, which contain the OH or hydroxyl group. And when these alcohols are dehydrogenated, we get a dehydrogenated alcohol, or we know it better as aldehyde. And from secondary alcohols, we get ketones. Aldehydes and ketones both contain carbonyl groups, but aldehydes contain these at the end of the chain, while ketones have these carbonyl groups in the middle or towards the center of the chain. Carboxylic acids, on the other hand, have a carboxyl group. It is a carbonyl group bonded to an OH. Esters, meanwhile, are derived from an acid in which at least one hydroxyl group is replaced by a single bonded alkyl group. We also have amines, which are formally derivatives of ammonia, wherein one or more hydrogen atoms have been replaced by also an alkyl group. And lastly, we have also talked about ethers. Ethers contain an oxygen atom which is connected to two alkyl groups. I hope you have learned a lot today. If you have any questions, please do not hesitate to write down on the comment section below. Thanks for watching today's episode of Organic Chemistry Made Easy. Once again, this is Teacher Jai. See you next meeting.